Hi everyone. In this particular video, we'll go through 30 plus determinant problems and find out how to evaluate determinant using determinant properties and simplification. There are different clues and techniques used to solve determinant related problems. So I hope by end of this video, you would be able to catch all of these techniques and tips required to solve determinant problems. As a prerequisite, you should have gone through earlier video which is related to determinant properties and evaluation of determinant. Let us solve few determinant related problems where without expanding, we will have to figure out the determinant. So we will have to either use determinant properties or simplify the elements in this determinant, right? We make the elements smaller and simpler and then calculate the determinant. Now in this particular example, without expansion, we will have to show that determinant is 0. There are two cases. In the determinant properties, there are two properties where the determinant value is 0. One is when the rows are identical. Either the rows or columns are identical, or if there's any one particular row or column which has all zeros in it, then we can say determinant is 0. Now let's figure out a way if we can get identical rows, or at least if we can get any particular row or column having all zeros. Now if you look at this determinant, you have one row which has all ones, right? So one way is you can have another row which has ones again, right? If you have another row with all ones, then you will have identical rows and you can conclude the determinant is 0. Now you can add, one method is you can add x plus y plus z, right? If you add row 2 with the row 3 like this, if you add row 3 with row 2 and modify row 3, then you will get x plus y plus z, right? And then you can take x plus y plus z as common outside and then you'll get 1 1 1. So this way we have two identical rows. Now since there are two rows which are identical, we can conclude that determinant is 0. So let's look at another problem similar to the earlier one. Here there are, instead of 1 1 1, here it is 3 3 3. So what we can do is we can again take 3 as a common factor outside. If you take 3 as common factor outside, then you'll get 1 1 1. Now we need another identical row, right? Like earlier, we can add y plus z and x. That is, we can add columns here. We can add column 1 with column 3, right? We can add that and then you'll get x plus y plus z. Then you can take that as a common element and then you'll get 1 1 1. So now you have two columns which are identical and thereby determinant is 0. So one thing is either you can update column 1 or you can update column 3, right? You can add column 1 to column 3 and modify column 3, or you can modify column 1. Either one of them we can do. Here again in this particular example, we'll have to show that this particular determinant is equal to 0. There are two properties in which the determinant is 0. One is identical rows and one is if a row or column has all zeros, right? If any row or column has all zeros, or if you have identical rows, right? Now in this case, getting identical rows is tricky because all of the rows have different alphabets. There is no similarity at all, because of which it's difficult to make two rows as identical. So easier way is to make one particular row or one particular column as zeros. So now if you try to add all of these three columns, if you add this, you will see that it will get cancelled. Here it's minus y plus y, it will get cancelled. Here it is minus z plus z, it will get cancelled. And x will get cancelled. So which means you'll get 0. So you repeat this for all the elements of column 1. So you will get 0 in column 1. Since you have all zeros in column 1, you can say the determinant is 0. You can do this for any column, right? It is not necessary that you do it for column 1. You can do it for column 2 also, column 3 also. This is another example. This is slightly tricky. We'll have to use another property here, property number 5. Because if you see here, there is a subtraction of two terms, right? There is a property in determinant which says that if you have elements as sum of two terms, right? Remember a plus kb 1, a plus kb 2. If you have something like this, then you can split the determinants, right? You can split the determinants like this. You can have 1a square and this minus bc minus ca minus ab. These three things can get into another determinant like this, right? So you can split the determinants based on property number 5, right? Now we individually will find determinant for this and for this. What we can do for this particular determinant is we can do row operation. That is, we can subtract row 2 and row 1. If you subtract row 2 with row 1, then you will get 1 minus 1 as 0, right? Basically, you have one column which is having all ones. You can try to make them as 0. First possibility, see if you can make this entire column as zeros. Or at least try to get maximum number of zeros, right? Because if you have maximum number of zeros, then calculation becomes easier. So that should be one more clue where you try to get zeros in a determinant. Now what you can do is, if you do 1 minus 1 here, it's going to be 0. Then you can do b minus a, b square minus a square, right? Similarly, you can do for row 3 also. 1 minus 1 is 0. So you'll get 2 zeros here in this particular column. You'll get 2 zeros, right? This is another clue, right, to simplify determinants. Whenever you have to simplify, the first method is to ensure or to see if you can make the elements as zeros. Apply some operation, be it subtraction or addition, right, between rows and columns to get zeros. Now, one more thing what happens is here, you'll have b minus a and c minus a, b square minus a square. Now, b square minus a square is nothing but b plus a into b minus a. B plus a into b minus a is nothing but b square minus a square. So you can write this like this as b plus a and b minus a. Now you can take b minus a as common because this is having b minus a. Here also there is b minus a. Take this as common and then you'll get 1 and b plus a left over. Similarly for third row also, you'll take c minus a as common. Now if you see, this determinant is becomes simplified. So you have 2 zeros and you have 2 ones. So it is simplified, right? Now you can apply determinant calculations. That is, you can take the column in which has maximum number of zeros. Here C1 has maximum number of zeros. So calculate determinant using this column, right? So this is the first element, 1 into cross multiply here. Then 0 and 0 you can ignore. So it becomes simplified now. 1 into, when you cross multiply, you'll get determinant like this. Now let's do the same thing for the second determinant also, right? Here also you can apply the subtraction technique. If you do subtraction here, 1 minus 1 is going to become 0 for row 2, and similarly you do the same thing for row 3. So you'll get same thing. Again here you'll have b minus a, and here you can take c as common, and again you'll get b minus a. So you can take b minus a as common, c minus a as common, and then expand the determinant or calculate the determinant using this particular column C1. Now when you try to simplify, you're going to get 0 as the answer. So here we have all numbers in the determinant. So what we can do is, we will have to somehow figure out a way where you can have 2 identical rows, or you can have one particular row with all zeros. Now it seems that making 2 identical rows would be slightly simpler, because if you notice, all these elements, they are nothing but multiples of 3. So what you can do, you can take row 1 divided by 3. So if you divide by 3, you will get 81, 50, 200, which is same as row 2. Now you have identical rows. So thereby you conclude that determinant is 0. So this is another example where you can simply subtract between the rows. 2 minus 1 is 1, 3 minus 2 is 1. So in this way, you will get identical rows, and then you can prove determinant is 0. Similarly, this is another example. Here, if you see, the difference between row 1 and row 2 is 3. Row 2 and row 3 is 3. So since there is a common difference, it becomes easier to make the rows identical this way. Then you take the common factor out, and then the rows will become identical. Now here, in this case, you'll have to figure out a way in which you can get the rows identical, right? Because it's difficult to make one particular row as all zeros, because you try to add this row and this row or this row, you do any combinations, it's difficult to get 0. So then in that case, you'll have to quickly see if you can make identical rows. So what we can do here is, we can take row 1 and row 3. Here you have plus y and you have minus y. So our objective here should be to make the elements smaller, simplify it basically, right? So if you add this row 1 and row 3, y and y is going to get cancelled. Then we are left with 2x, right? Like this, 2x. So now you can take 2 as common and you'll get x, y, z. So the rows are identical. Here there is a tricky problem where you'll have to prove that determinant is a into b. Here it is not 0, but you'll have to prove that determinant is a into b. So when there is something like this, try to simplify. That is, try to make few elements as zeros. Try to make it as zeros, right? You can choose any element. You can choose this element and try to make it 0. How you can make it as 0? By subtracting this row with this particular row. It becomes 0, right? Or you can choose to make this as 0. How you can make this as 0? By subtracting this element with this particular row. Then it becomes 0, right? You can also choose this element. Either you subtract this element with this one or this one, then also it becomes 0. So there are multiple ways. You can start with any element, right? And then apply a row operation. So here we have done a subtraction between 2 rows, row 2 and row 1. row 3 and row 1. You can also do column operation, right? You can do a column operation, even then you will get the same result. So now, if you do these 2 row operations, you will get here 2 zeros, right? So when you get 2 zeros, that means we have reached the simplification. That is, we have achieved the simplification. Because when you have 2 zeros, it is easier to calculate determinant. How? You will take this first element, cross multiply a into b, then minus 0 into 0. So it becomes easy. But remember one thing, there is a property here, property number 8, which states that this is the principal diagonal. If there are zeros on one side of the principal diagonal, you have 3 zeros here. So if there are zeros on one side of the principal diagonal, all zeros, right? Then the determinant is nothing but product of all the elements. 1 into a into b is the determinant for this kind of a matrix, where on one side of the diagonal all are zeros. This is property number 8. This example is also similar, just that instead of 1 plus a, it's 1 minus a. Apply the same operations and use property number 8. Third main, the problem becomes slightly complex. Here you'll have to prove or get the determinant value. We will have to first see if we can simplify. How we can simplify it? One way is by making the elements as zeros. There should be some way by which you make the elements as zeros, right? You start from there. You start from there where you can make certain elements as zeros. Step 1, see if you can make elements as zeros. Step 2, see if you can take common factor. Some operation you do by which you'll get some common factor, and that will simplify. These are 2 steps that you'll have to first think before starting the problem. So now here, I would want to make these elements as zeros, right? At least some elements. So what I will do, I can take column operation. Because if I subtract this one with this one, it's going to become 0. So I'll start from there. I'll do C1 minus C2. Similarly, I can take this column and make another element as 0. You start from there and slowly you will figure out that you'll get this one. Slowly you'll figure out that you can take a common factor now. Here you have b minus c and b square minus c square. So there are many problems where you get something like this. B square minus c square, a square minus b square. Whenever you get this, you'll have to apply this a plus b into a minus b formula. A plus b into a minus b is a square minus b square. You have to use this. And then you can take the common factor outside. Now you see that you have 2 zeros in one particular row. That means you have simplified. You have simplified to a great extent, right? So now you can directly do the determinant calculation. So take the row in which there is maximum number of zeros, that is row 1. Take this element and apply determinant calculations, right? So you'll get 1 into a plus b minus 1 into b plus c. That is expanding along row 1. Since it has 2 zeros, you will get this as the determinant. So this is nothing but equal to RHS. This is a similar problem. The approach should be same to make the element as 0, right? Try to make this as 0, try to make this as 0 or this as 0. So somehow you can make 2 elements as zeros here by applying row subtraction, right? Then once you get zeros, then you will automatically see that you will get some common factors also. Take those common factors outside and then expand. Now that you have 2 zeros and you take the common factor outside, this one, you will get this kind of a determinant. Now you try to expand it. Take this 1 as the element, cross multiply and then subtract. So that is called expanding along C1. That is, you are using column 1 and trying to figure out the determinant. Ignore this row. You are left with these elements, 1 c plus a, 1 c plus b, cross multiply and then subtract. So here you have the RHS. Again, another similar problem, just that you have cube here, right? Earlier problem you had square, here you have cube. Now here, same thing, try to make the elements as zeros. Remember these tips and clues. First step is, the way you should think is, first step is check if you can make the elements as zeros. Then second step is see if you can find some common factors. Now here you have c cube minus b cube. Remember this, c cube minus b cube is nothing but c square plus b square plus cb into c minus b. This is the formula for c cube minus b cube. Remember this. So a square minus b square is a plus b into a minus b. A cube minus b cube is equal to a minus b into a square plus b square plus ab. So remember these two formulas, and then it becomes easier to solve these kind of determinant problems. So here if you notice, in this particular column you have c minus b as common, and in this column you have a minus b as common. Once you take the common factors outside, you can expand the determinant or calculate the determinant. So use this particular row 1 because this row has maximum number of zeros. Now you call it as expanding along row 1. Expanding along row 1, find the determinant. So you will see that you will get this particular determinant value, which is nothing but equal to RHS. This problem is even more complex, but the approach is same. All these are related problems, but approach is same. Make the elements as zeros, expand c square minus b square as c plus b into c minus b, and c cube minus b cube also you expand like this, and then take the common factor outside, and then perform the expansion or figure out the determinant. Another similar problem, right? Approach is again same. The reason I'm going through so many related problems is so that you can quickly catch the technique or the steps which you'll have to start with. So here again, you have a column with 2 zeros after applying this row subtractions, and then you will get the common factor out, and then you have the final determinant. Here there is another problem. This is slightly tricky. This is another property. If you notice, all the terms here in this column C1 is a sum of two terms. When you have a column or a row with all elements as sum of two terms, then you can split the determinants. This is property number 5. Property number 5, you can split the determinants like this. You split the determinants, one with a square, b square, c square, and one with bc, ca, and ab. Like this, you split this. Then independently, you apply the row operations on this one and on this one. Operations need not be same. You can apply different operations, right? It's not necessary that you apply the same operations on this one and this one. It can be different. Now here again, the approach is same. Try to make these ones as zeros, and then you'll get common factor. Because of subtraction, you will get common factors. Here for the second determinant also, same operation will work, but it is not necessary. It can be different as well. After getting the common factors out, you can expand. Expand along column C3 because column C3 has maximum number of zeros. Let's go to the fourth main. Here you'll have to prove that this is the determinant value for this particular determinant. So you take the LHS. LHS is this portion. See here there are two techniques actually. See, one thing is you have similar terms. X plus A, B, C. X, B, C, A, B, X, C. So all similar. So what do we do when we have similar terms? Add the columns. Just add the columns. When you add the columns, you're going to get X plus A plus B plus C. You're going to get common factor. Take the common factor out, right? As we have done in earlier problems. But another approach also is there. I've used the other approach here just to show that there is an alternative way of doing also, right? Use alternative way is you have A and A here. So when you have A and A here, you can make this a 0. A minus A is 0. You have C and C here. So when you have C and C, you can make it a 0. B and B, you can make it a 0. So you can apply 3 operations and make the elements as zeros here, right? So you take row 2 and you make this element as 0, right? Now you take row 3 and make this element as 0, right? Now you've taken column operation, made this element as 0. So you can go step by step, start making elements as zeros, and then finally expand. This is one way. Otherwise, the other way, which normally we have used in so many problems, is add up all these. There are multiple ways, right? Whichever comes to you first, whichever strikes you the first, go ahead and do it. First row 2 operation you do, you'll get this element as 0. Then you can, from this, you can find the common factor, A plus B plus C. So you get A plus B plus C as common here outside, right? You can take A plus B plus C as common. You can also do a row 1 operation, make this element as 0. Here also you get A plus B plus C. So this row also has A plus B plus C, this row also has A plus B plus C. So you can take the common elements out, common factors out, and then you'll get this particular determinant. This is far more simplified, but still you can simplify. You can make this as 0, 1 minus 1 is 0, right? You can take this element and make it a 0. So we have made this element as 0. Now you expand and find the determinant. This is another problem. Same step. See, this is the other method that I was telling. Add up all these columns. Because you have the same alphabets, A, 2B, 2C, right? You have same alphabets, A, B, C, A, B, C, A, B, C. So you add up all that, and then you're going to get common elements. Take it as common factor. You'll get 1 once, then make it as zeros. Now you make it as zeros using row 1 and row 2 operation. Same approach, right? Now once you have 2 zeros, and once it is fairly simple, it has become fairly simple here after taking common factor out. Now you can expand along C1. Why C1? Because this has maximum number of zeros. You can also take row 1. You can also take this row 1 because this also has 2 zeros. So this is the fifth main where you have to prove that determinant of this particular matrix is 4 into A into B into C. You have a lot of problems like this, right? All similar problems. just that you'll have square, cube, right? So same thing. Here you have B, C, C, B. Same thing, same alphabets. So you try to add up all the columns. You'll get this becomes 0. Here all the elements are not going to become 0. Only first element is going to become 0. But second and third is going to have common element, right? Minus 2a, minus 2a. So you can take 2a as common here now. So we get 0, 1, 1. Now we can take it to next step. Try to make this one also as 0. If you make this one as 0, then you're going to get this particular determinant. Now it is fairly simple because you've got 2 zeros and all others are simplified. So now you expand along C1. Why C1? Because this is having maximum number of zeros. So you evaluate and you're going to get 4 into A into B into C, which is equal to RHS. Basically you start with LHS. LHS is this portion. LHS is equal to this. Then you keep on doing the row operations and you'll get the determinant value. This should be equal to RHS. Yet another problem. So here you cannot add columns. You cannot add columns like earlier problem because here everything is different. Here it is A square, here it is B square, here it is C square. So even if you add the columns, you're not going to get any common element. So you can't use that approach. You can't even do subtractions here because by doing subtractions, nothing is going to become 0. So both the techniques are gone in this particular problem. So what you'll have to do is see if you can take the common factor out. Common factor is here you have common factor. A is common here. Here you have B. Here you have C. So we'll take the common factor. If you take A as common, here you'll be, since there is 1, it will become 1 by A. So taking common factor is nothing but dividing, right? If I have to take a common factor out, then it's nothing but dividing. That is A square plus 1 by A, AB by A, AC by A. This is what is called as taking the common factor out. So I'm taking common factor out, which means I'm dividing each of the elements by A. So now what's going to happen when I divide? It's going to become A plus 1 by A, B and C. Right? This is what is going to happen here. And B square plus 1 is going to become B square plus 1 by B because you are going to take B common here. This is nothing but B plus 1 by B. Right? Here. Similarly, C plus 1 by C. Now if you notice, these two are common, identical. So subtract. These two are identical, subtract. These two are identical, subtract. So you will get this kind of a determinant now. When you do all the subtractions, you're going to get finally this particular determinant. Now you can't do anything further. You can subtract these elements. You can subtract these elements, then it will become 0. But the problem is this will become 0 and this will become 1 by B. So there's no point doing any operation now here at this point. If you try to make this a 0, this will become something else. So there's no value in doing it. So stop it here, expand it, right? Take this particular row, expand, calculate the determinant. See, if you see that there is nothing that you can do, no operation you can perform, then simply go and expand it and find the determinant. Like this. So this is another example. Here you have same terms, B square, C square, A square, B square, C square, A square. So you can add all the columns here. Or you can add even the rows here. But the problem is if I add, still I will not get a common term. Why? Because first row I'll have 2A square. Second row I'll have 2B square. Third row I'll have 2C square. There is nothing common, right? Ultimately. So what we can do is, we'll come back to the last approach of making it as zeros. Now if you notice here, if you add B square plus C square and subtract it with this B square plus C square, then it's going to become 0. B square plus C square minus B square minus, that is you're going to add these two rows and subtract it with this row. It's going to be row 1 minus row 2 minus row 3. Right? So this way, this element is going to become 0. You will also get some common constants. You'll get some common numbers 2 here. So take the 2 outside. You'll get a determinant like this. Now what next? Next is I have C square and C square. So I can subtract and make it as 0. Right? Take that as second step. Now third step, I can subtract this also and make it as 0. Like this. Then here we have reached a state where we can't do any further calculations or simplifications. Nothing you can do. So now you expand it. You expand it. Right? And then get the determinant. This is equal to RHS. Yet another problem. You have to prove that this is equal to 4 into A into B into C. What we can do here. Here you have B plus C, B plus C. C plus A, A plus C. So like earlier problem, you can try to take this B plus C, subtract it with this. C and C will get cancelled, B and B will get cancelled. you'll take column operations. You can take C1 is equal to C1 minus C2 minus C3, right? Alternatively, you can also do the same thing with row. B plus C, you do minus with this, this will get cancelled, right? So you can take row 1 as row 1 minus row 2 minus row 3. You can do any operation. So you'll get a common factor out. You'll get this 1, 1, 0. 2a is the common factor. Now what we can do, you can subtract these two. 1 minus 1 is going to become 0. So apply a column operation now. Column operation. C2 is C2 minus C3. Apply column operation. So once I apply column operation, this is going to become 0. This is already a 0. Now expand it along row 1 and find the determinant. So this is equal to RHS. You'll get 4 into A into B into C, which is RHS. Let's go through another set of questions, right, where we will have to solve. When you say solve, it means find out the value of unknowns. Find out the value of X. That is what is called as solve. Solving the determinant. So you figure out the values of X. They have already given the determinant value. 0 is the determinant value. So when you find the determinant of this particular matrix, you should get 0 as the determinant. Then with that you can figure out the value of X. See, one clue here is, you see the numbers, there is a pattern here. You have same kind of numbers. 3, 4, 2, 4, 2, 3, 4. You have same kind of numbers. So this is one clue. So what you do is you add all these. You add all the numbers here. X plus 2 plus 3 plus 4. X plus 2 plus 3 plus 4. Numbers are same. So obviously when you total it up, you're going to get the same number like this. When you total it up, you're going to get X plus 9. So this is a clue. When you're going to get the same number, that means you can take it as common factor, right? Now you'll get this. Let's see if we can make certain elements as zeros. We can, right? 1 and 1 is 0, 3 and 3 is 0, 4 and 4 is 0. When you subtract these elements, it's going to become 0. So you can apply subtraction on the rows, right? So now you're trying to make the numbers as zeros, trying to make the elements as zeros. So simple. So row 1 minus row 3, row 3 minus row 1. When you apply these two operations, you're going to get these two elements as zeros. All these elements are going to become zeros. Now the determinant is looking simpler, right? Now you can expand it. Since you already have 2 zeros, you have 2 zeros here in this column, 2 zeros in this row also. So either you can take this column and expand, or you can take this row and expand. Either way, the answer is going to be the same. So you can calculate the determinant here like this, right? Or you can take this one and figure out the determinant. But the determinant is already given as 0, right? So equate this. X plus 9 into x square. They've already told the determinant is 0. Now when you equate, what will happen is, you will have to split this. X plus 9 is equal to 0. X plus 9 is equal to 0. And x square is equal to 0. You have to split like this. So this means x is equal to minus 9. This means x is equal to 0. So you have two values for x. So we have figured out the values for x. So we have solved this particular problem. So this is another problem where we have to solve. Solve meaning we have to find out the value of x, and determinant value is given as 0. Now this is another clue, right? You can say this is another clue. You have same numbers in all rows and columns. 3x is there, 3 is there, 8 is there, right? All the rows are having 3, x and 8. Same pattern. So when you have similar pattern like this, try to add the columns, right? When you try to add the columns, it's going to become like this. 3x minus 2, 3x minus 2. So this becomes common. Take it as a common factor outside. So you'll get all 1 1s here. Now simple. Now you try to make the numbers as zeros. You can make this 3 as zeros, right? By doing a row subtraction. 1 as zeros. Apply that subtraction operations. You can either do it on column or you can do it on rows, whichever, right? Now you have the common factor. You have the elements as zeros. You have two elements as zeros. So you can pick row or column and expand it, right? And determinant value is told as, determinant value is 0. You have these many terms. You have 1, 2, 3 terms. So individually we'll have to take 3x minus 2 is equal to 0. 3x minus 11 is 0. Again this one also 3x minus 11 is 0. Which means x is equal to 2 by 3, x is equal to 11 by 3, x is equal to 11 by 3. So these are the values for x. And one more thing I forgot to mention here. Here the determinant is the product of the principal diagonal. This is the principal diagonal. If you notice, all the elements besides the diagonal is zeros. All these are zeros, right? Since all these are zeros, the determinant is 1 into 1 into 1. This is the determinant. 1 into 1 into 1. 1. So this is by property 7. So again, this is another related problem. If you see 2x, 3, 4, there is same pattern, same numbers are there. Add the columns, take the common factor, and then apply the row operation, make the elements as zeros. Then get the determinant. Here, determinant is product of the elements, because on one side of the diagonal all are zeros by property 7. Now you will get x plus 1 into x square. So which means x plus 1 is equal to 0, x square is equal to 0, thereby x is equal to minus 1, x is equal to 0. Individually you have to find out the value of x. Same approach. Add all the columns, take the common factor out, make the elements as zeros, here, right? And since elements are zeros on one side of the diagonal, determinant is product of the elements, and the determinant is already given as 0 in the problem. Equate it, find the values of x. See, here you will get 3 expressions. X plus 1 is equal to 0, x minus 2 is equal to 0, x minus 2 is equal to 0. Now you figure out the value of x becomes minus 1, x becomes 2, and x becomes 2 here. Similar problem, 3x, 6, 3, same numbers, add the columns. Same approach, right? Common factor, x is the common factor. Then make the elements as zeros, elements as 0, expand it along this column, along C1, and then you have the determinant value which is 0. You will get 3 terms. Remember one thing, don't expand these terms, in the sense don't multiply x into 9, x into x. Don't do the multiplication, leave it like that. Leave it as is. Don't multiply, because you have to find out different values of x. So what will happen? Minus x is equal to 0, 9 minus x is 0, minus 9 minus x is also 0. You separate into 3 particular values of x. So minus x is 0 means x is 0. 9 minus x is 0 means x is 9. Minus 9 minus x is 0 means x is equal to minus 9. Similar problem, related problems, right? I think by now you would have already caught the technique. Property 7. One side of the diagonal is zeros. Property 7. Multiply the diagonal elements, right? I hope you have by now got by hearted with properties and also the techniques. So the more you solve, it's going to be very easy. Now this is tricky. This is tricky because the numbers are different, right? Here you have 6, 1, x. Here it is 3x, 2x. All the numbers are different. So adding up all the rows will not serve the purpose. You cannot add all the rows or columns. It's going to give different values, different answers. You can't take the common factor. So now we'll have to figure out another clue or another technique, right? So the technique here is simple. If there's nothing, if you cannot think about anything, try to make the elements as zeros. That's the best way to simplify the determinant. See if you can make any of these numbers as zeros. So I can see 2 and 3 is fairly simple. So what I will do is, if I multiply this with 2 and this with 3, it will become 6 and 6. 6 plus 6, if I add these, it's going to become 0. So basically you're taking row 2 elements, multiplying by 3. All of them you multiply by 3. Then take row 2 elements, all of them you multiply by 2. And then you add these two. Why we are going to add? So that this will get cancelled. This will get cancelled and it will become 0, 0. This will become 0. That's what we're trying to do. This will become 0, right? Then as you keep solving, you'll figure out that there is a common factor also, right? When you do addition operation here, you'll get some common factor like this. Now you take 5 as common, right? In this row 2, 5 as common. So you'll get this, right? Now, see if you can make another element as 0. Because if you can make another element as 0, then you can expand the determinant directly. So you have already 1 0 here. You need another 0 in this particular column. You can see if you can make minus 3 as 0 or x as 0. There is no way you can make x as 0 because there is nothing here by which you can make x as 0. Can we make minus 3 as 0? No, we cannot make minus 3 also as 0 because none of these elements with these elements you can't make this as 0. So now what next? So we cannot do anything with this. See if you can do something with this second column. In second column, what can I make it as 0? Here you have related terms, 2x and x. So if I multiply this with 2, then and if I add this is going to become 0, right? I'll get minus 2x plus 2x. This is going to become 0. That means I can make this as 0. I can make this a 0, right? That is one thing that I can do. See, this problem is slightly tricky because here there is no common element, there is no identical elements, right? So in this case, we will have to go step by step, figure out if you can make any element as 0. If you have made one element as 0, see if you can make another element as 0 in the same column or same row. If you cannot do that, then jump over to the next column. If you cannot do anything here, then jump over to the third column, right? So this will take a little bit of practice, and as we keep practicing, this will strike us immediately. So here we'll make 2x as 0 like this. Now when you do this operation, you're going to get 3 as common here. So we'll take 3 out. So we've taken 5 and 3 out. Now I don't think we can do any further simplifications, because if you see, all the numbers are different. Any operation you do, it's not going to become 0, right? So that's why we will directly do the expansion now. You can take this row or you can take this row. Both of them are same because both of them has 1 0 only. So expand along second row and then you equate it to the determinant. They've given the determinant as 0. Then don't expand the terms. Leave the terms like this: x minus 1, x minus 2, x plus 3. See here, when you multiply, here you have numbers, so you'll have to multiply. You'll have to multiply this. X into minus 6, minus 1 into minus 6. You have to multiply here, right? Then you'll get this quadratic equation. You will have to find the factors of this equation. When you have some equation like this, how do you find the factors? You can use sum product method and get these factors. So you may want to watch a separate video on how to figure out sum product, how to solve quadratic equations like this using sum product method. There are separate videos in my playlist. You'll have to refer that. This will need a little bit of practice to arrive at these factors. Now, when you solve this using sum product, you'll get x minus 2 and x plus 3. Then you separately take x minus 1 as 0, x minus 2 as 0, x plus 3 as 0, and then you get the x values. So I've covered more than 30 plus problems related to determinants. I think by now you would have caught up with all the different approaches, different clues, different techniques in which we can solve determinant related problems.